The last part of section 1 is dealing with function notation. So instead of having y equals, we are now going to have this symbol. So the way we read this is f of x. Okay, so f of x. This does not mean f times x. Okay, so don't confuse that. So this f, that represents the name of our function. So this is the name of the function. So that can really be any letter that we want it to be. It could be a G, it could be an H, it could be an M. If we really want, we could do a heart for a symbol, but it's just the name of the function. Okay. The parentheses, okay, that is our variable that we're going to replace. Okay, so variable to replace. Okay, so the letter on the outside is the name. This is what we're replacing. Now the parentheses is just, again, we want to use that when we do our substitution step. So this is going to be very similar to evaluating when we start working with that. Again, the x represents the variable in our equation that we're going to replace. And it doesn't have to be an x, so this could also change. It could be a y, it could be a z, it could be an m. There can also be more than one if we needed to, but that won't be until you get higher up in math. And again, this f of x, we're just replacing our y in our equation. Okay. So this, if we look at an example, so here if we read this, this is f of x equals 3x plus 2. And again, it means the same thing as this equation. So y equals 3x plus 2. Okay. Now, we're not solving for x, so there's not really two x's here. So again, this is the name of our function. This is the variable that we would replace if we need to. So with function notation, we typically use this when we are working with more than one function at a time. So we're kind of giving them names. And we're also going to be using it to evaluate. So it becomes a shorthand for evaluating expressions too. So that's what we're going to practice next, is evaluating with function notation. Okay, so here we are given two different equations. So we have f of x equals 2x minus 3. And g of x equals x squared plus 3x plus 2. And we're going to evaluate each of the following. So for 10, when we're looking at this, this is telling us what function to use, and this is telling us to plug 4, or substitute 4, into all the x's. Okay, so when we do this, that means that we're using this equation, so that 2x minus 3, and I'm going to substitute 4 in for the x. So 2 times 4 minus 3. And then we're just using order of operations to simplify. So 2 times 4 is 8, minus 3 gives us 5. So we're simplifying these down to a number. Now you're also going to see this written like this, where it's f of 4 equals that. That does not mean to solve. So we're not solving anything in here, we're evaluating down to a variable. So the other thing that this tells us is that if we write it as a point, our x value is 4, and our y value is 5. So if we were to actually graph this equation, this is just a linear equation, so it'd be really easy to graph. On the graph, I could go over 4, and if I went up, I would meet the graph at 5 for the y value. All right, let's try another one. So here, this time we're using the g equation, and we're substituting in -2 for all the x's. So we're replacing this x with 2, -2, and this x with -2. So -2 squared plus 3 times -2 plus 2. So here our squared is on the inside, so that negative is on the inside. So when we square it, it becomes positive. So this is 4, and then minus 6 plus 2. Again, we just keep combining. So 4 minus 6 is -2. And if we add 2 to that, we end up with 0. All right, here this is telling us to substitute f into f. So we would have 2 times -1 minus 3. So -2 minus 3 is -5.